AWS Loft Talks.
I'm William Josephson. I'm one of the co-founders at Solano Labs, and we help a lot of our customers run their continuous integration process. And we'll be talking about the importance of performance and basically automation for your continuous integration workflow. Kind of take a step back and say, what's the problem we're trying to solve? I don't know how many of you remember the old build box in the corner under the desk. When I started in the Valley, it was a nightly build. It was a box under the desk, and when the rainy season came, the power went out and your build box crashed. And hell, if you could get it back up and running, you hoped it was still powered up. You hoped that it hadn't lost all its configuration, because the first person to touch it was the person who's going to have to keep touching it. Now, of course, we automate everything. We test everything. And I think it's not just, you're not just doing a nightly build, you're not just testing your master branch, your production branch. You're able to do it on every feature branch. You're able to do it on every commit. And it's become a core part of your business process. And I think the other observation, because everybody's been talking about the importance of DevOps and basically turning your infrastructure into programmed infrastructure rather than manual, I think going back to what you were saying about the importance of testing for infrastructure, that's what we're finding too. A lot of our customers are actually starting to run things like, if they're using Ruby maybe RSpec instead of the Chef testing tool, but they're testing their Docker images, not just their software. And so the important point is you can't improve your operations if you can't test it, if you can't you don't have numbers to put to it. You fix what you measure. That it's only scalable if it's automated, and automation is most valuable if you've got it completely, if you've got the infrastructure automated as well. So I think the key things that we emphasize with our customers, it's fast, it's reproducible, and it's available. All of this fancy automation is no good if knocking over one server takes it all offline. In fact, you're actually worse off than when you started. So first of all, let's talk about why is the speed so important. You've got a complete build process and a thorough test suite, and it just took your build process from 10 minutes to 10 hours. Now what? Are you going to sit there and wait for it all? Even if the individual build is fast, now you've got everybody doing their own feature branches, and it's all backed up. And so, the thing that we see is that people come to us because they have some testing, but it's backing up, and they're having to make some tough decisions. Do I want to deploy, even though I haven't really been able to test it all? How do I get rid of the shortcuts, the hacks, the one-offs in my process? The second and harder part is often reproducibility. Automation is great, and when you first get your automation out there, everybody's happy. It's humming along, it's fast, and then suddenly you hit your first flaky test, your unreproducible result. And it's not so bad. You rerun it, you try it again, and you move on with life. But they tend to accumulate over time. You end up with not just engineering debt, but testing debt, effectively. So what we advocate is taking a DevOps approach, not only to your applications, but also to your infrastructure and to your test infrastructure, making sure everything is easily reproducible, that you have known good configurations, that you version your configurations for your tests along with the repository that has your code. You have a complete version history of everything. And your entire environment is defined through automation and configuration. So this kind of goes back to the pets versus cattle argument. Too often CI environments require careful care and feeding. A lot of the package software approaches that are pre-DevOps have this problem. You lose the master and you don't have it backed up. It's not version. What version? The person who was doing the care and feeding has left the company, now what? So the worst case really is that no one understands the configuration, how to build a new test environment from scratch. And we've seen that even with very large customers that have dedicated teams. Availability is another thing that a lot of people don't worry about too much when they first start. It's that server under the desk, or it's the small instance that we booted in Amazon, and it seems to just hum along until one day you go and you go to look at it, and there's been a VM has crashed, a kernel panic, and the thing is gone. So the problem there is, of course, that your business doesn't stop just because your test infrastructure stops. A properly built out continuous integration workflow is one in which it's become a part of the critical business process. So you have to treat it with the same level of seriousness that you are the rest of your infrastructure. So a good CI system anticipates failure. You have a serious disaster recovery plan in place, and you have adequate backups. You have to have a high availability control plane for it. If you don't want to have to rerun all your builds or be offline if one of the master nodes disappears. That's no good. And furthermore, what we find is that a good CI system has to anticipate and handle worker VMs that crash, that worker VMs that, something's a little off with the hardware. Well, it's much easier to just go into your console or into your CI system and say, get rid of that VM and let's move on with life, than it is to figure out exactly what went wrong in a long-running build. So I think one of the key things here is that the DevOps approach in general allows us to have disposable components, and you should apply that to your continuous integration and delivery system as well. That allows you to deal with failures and to deal with scaling in a way where they're non-events. It's just a click of the button, or even better, an algorithm just substitutes in a new one for you. Our high availability scale-out architecture is made possible by the Amazon building blocks. It's not going to become a huge surprise for any of you who are using Amazon in a significant way, but we use EC2, and we have strong support, native support for VPC. A lot of our customers are deploying everything in VPC now. And so the control plane, and in fact in our system, each tenant can be in a separate VPC. You can have some parts of your system maybe need to be partitioned from others. You have a component of the CI system that can be used by offshore contractors, and another part that's only has to be US persons. So you can put those in separate networks. Need more compute? Sure, just add more. We can run thousands of slaves at once. The control plane to support that has to be scale out as well. So you use things like ELB and Elasticache to make that happen seamlessly. And then another thing, especially now that S3 has high performance endpoints inside VPC, we can push many, tens of gigabits through S3 to serve up content to all those parallel workers. And then the last component here, one that a lot of people don't think about, is a lot of our customers end up with rather large Git repos or Mercurial repos. They're not just 100 megabytes. They've put everything in there. They're 5 and 10 gigabytes. And so how do you move that around in an efficient way? We offer a caching solution for that so that they can have their primary, they may still have their primary Git storage on-premise. They may have a requirement to have it on-premise, but they don't have to push 5 or 10 gigabytes of code up every time.
AWS Loft Talks.